anything, you're going to look to see how many atoms of each, and then use a prefix to indicate how many atoms. So there's 2 atoms of nitrogen, so the prefix that represents 2 is di. So you write down dinitrogen, nitrogen. And then 4 is tetroxide. So you still change the suffix to an "ide." So when you have 2 nonmetals, nitrogen is on the right-hand side of the periodic table, so it's a nonmetal. Then you use these prefixes to indicate how many you have of each atom. Because nonmetals, covalent compounds, 2 nonmetals bonded together could be in multiple ratios. You could have carbon monoxide, carbon dioxide. So it's not like ionic compounds that will always form in the same ratio. Covalent compounds will be different ratios. Okay. Might be a lot of information, but let's move on to the second half of this worksheet, which is way over here. Okay, so for this one, you have the name of it, and you need to find the formula. So you start with nickel. Nickel is a 2+ because you see that 2 in Roman numerals. Chlorine, you look at your periodic table, or it's found on the ion sheet. Chlorine is in group number 17, so it wants to gain 1 electron, making it a -1 charge. So how to figure out the formula, you take these numbers and you switch them. You don't bring the negative or the positive with it. Then you put Ni1, because there's a 1 by chlorine, it's -1. And then chlorine will have the 2 from nickel. Okay, I think we talked about, I'll just do random. We already talked about cuprous nitrate, but you can find it on the polyatomic ion sheets. If we go to carbon monoxide, this is a covalent compound because this is nonmetal and oxygen is nonmetal. So you have 1 carbon, and monoxide, mono means 1. So mono means 1, di means 2, tri means 3, tetra means 4. You won't have any, oh yeah, you do have a penta. Penta means 5, and it goes farther. Hexa means 6, septa means 7, octa means 8, and nona means 9, and deca means 10. But I don't think you see those on there. So mono means 1, so that's only 1 oxygen. So it's easier to figure out the formula of covalent compounds. Like number 20 is a covalent compound as well. You got sulfur, and then dioxide. Di means 2, so there's 2 oxygens. Okay, I'll do one more ionic compound, which is a nonmetal, or a metal bonded to a nonmetal. Let's do 14, magnesium. Magnesium is in group number 2, so it's a 2+ because it wants to give away 2 electrons. And nitrogen is in group 15, so it's going to be a 3- because it has 5 valence electrons. It wants to gain 3 to have 8, because 8 is that number that makes it stable. It's called the octet rule. So magnesium will get that 3 from nitrogen, and nitrogen will get that 2 from magnesium. And we'll do one that is a polyatomic ion, like ammonium sulfate. Ammonium, you have to look at your ion sheet and find ammonium, and I think we already did that for one above. Whoops, that's math. Ammonium. Where is it? We'll find it. There it is, sorry. NH4+ on the left-hand side there. So now we know it's NH4+ for ammonium, and then sulfate, NH4+, remember that, and sulfate is SO4 2-. NH4+ and SO4 2-. So NH4+ and SO4 2-. Switch these numbers to become the subscript, and then you get NH4, you get that 2. If you're needing to put another number down there, if there's already 4, you have to put parentheses around the whole thing. And SO4 1. So if I didn't put parentheses, it would look like NH4 2SO4. So it would look like you had 42 hydrogens. So you have to put those parentheses there. Okay, so that's how you do this worksheet. And if I can do one balancing equations, let's see if I can have room here. I'll find room on this document. Okay, I'll find room here because I didn't take a screenshot of the balancing equations. So I will do it right here. Let's say you have, CH4 and you're gonna light it on fire. That's methane. So you add oxygen when you light something on fire. Then you get carbon dioxide and H2O as your products. To balance an equation, so the purpose is, if you have two oxygens on the left-hand side here, and you can see on the right-hand side, you have two here and one here with water. So it's not balanced. You have three oxygens on the right-hand side, only two on the left-hand side. So we have to make sure that we have the same number of each element on either side of the equation, or it won't make any sense because matter can't be created nor destroyed. So what I do here is you make a list of all the elements you have in the reaction underneath the arrow. So we have C, carbon, we have H, and we have oxygen. So on the left-hand side, we only have one carbon here. On the right-hand side, we have one carbon. Hydrogen on the left-hand side, we have 4, and on the right-hand side, we have 2. On the left-hand side, we have 2 oxygens, and on the right-hand side, we have 2 plus 1 more is 3. So you can see the hydrogens and the oxygens are not balanced. So what I tell students is, if you had other elements to balance, save hydrogen and oxygen for last in that order, H before O, because it just kind of makes it easier to do that because usually they're together in like H2O or by themselves in H2 or O2. So I'll do hydrogen first. We need 4 over on the right-hand side. So whatever number you put out in front, that's going to be multiplied by the subscript. So we need 4 altogether. So if I put a 2 out in front, you multiply it by 2 and you get a total of 4. So cross out that number and put what you have now there. But take into account, if you put a 2 here, that's also going to change the number of oxygens because you have 2 H2Os and they're bonded together. So now 2 times 1, because there's nothing over here by oxygen, so now you have 2 oxygens here, and you have this additional 2 oxygens here. So that's a total of 4 oxygens on the right-hand side. So you have to recount the elements that you changed, because since oxygen is in this compound as well, you have to recount oxygen as well. So over on the left-hand side, now we have to change this oxygen from a 2 to a 4. So you can see it's O2, so whatever number we put out in front, we have to multiply by 2. So what number do you multiply by 2 to get 4? That'll be a 2. So 2 times 2 is 4. So now you see all of them are balanced. You have 1 carbon, 4 hydrogens, and 4 oxygens, so you're good. So that's how you do balancing. I can go through some more problems if need be after you work through that worksheet.